Hello, my name is Huber.
I'm Eric Roden.
And I'm Timothy Joyce, and this is our final class video for our capstone project. As exciting as it is, as much work as we put in, we're excited to share with you all that we've accomplished since our last progress report video early in the semester. So the way we ended our milestones back in our last video, we kind of had a working GUI there. A lot of progress was put into it over the winter break period and the early parts of the semester. The team was really heavily involved in working with the formulas and trying to get those in, as well as getting the loop filter, and for specific design, our active C filter. So since then, here we are now. We have all of that completed. We can honestly say that we have a minimum functionality completion of our GUI system. So now we can accurately depict, analyze, plot results of any real-world PLL that General Dynamics will want to use in the future using our active C filter. And now Eric is going to take it away and show you what progress has been made since the last video on the GUI itself.
All right, thanks, Tim. All right, and this is our finished product for demo day. As you can see, we've taken out a couple things that we didn't program in yet, but these are future things for General Dynamics. So let's just get into it. We have our test values. These are actually taken from a real-world PLL, so it actually gives real results. So I'm not going to go over all the numbers, but this is what we have. Still active A, we actually need to change that to active C, but anyways, so all of our real values, we've taken out these parts. Those are for future use. We'll just get into it. So as you can see here, we've programmed in the jitter, phase, all the VCO, all the parameters that General Dynamics wants. We've completed the open loop response, closed loop, reference phase noise, phase detector noise, VCO phase noise, and then this one just shows all of it. So I'll just go straight into showing all of it. So you can see the final product. And you can see they're all graphed over on top of each other. So in our noise contributors, we've taken out the ones that aren't relevant, but we've changed the design a little bit. Instead of having each individual box, these are all single boxes, and it turns everything into arrays, and this is how we calculate everything. So the ones that are filled are the ones we're actually using. If we change these, it will change our output. I'll just kind of scroll through a couple of them. So there's a lot of future use to this program that we didn't get time to put into it, but still, regardless, a great program. And then our export plot works also, so we can export our plots. If they want to save them, they can save them. You can get more accurate values by going over it. See, we got our X and Y. So everything works pretty well. That's kind of just the overview of the GUI that we have so far. And then Huber will explain what we're going to do for demo day.
For demo day, we're going to compare our tool to a real-world a PLL, which is going to be from a Hittite. So we're going to be bringing that eval board to demo day, and we're going to use a FSWP, a phase noise analyzer, to compare our results to that of the hardware. So our main focus on this program was to get the composite noise, which that's pretty much calculates all the total noise from the PLL. So we'll use that FSWP to compare that to our tool to kind of show the difference between that, and hopes to kind of have the same output. So what we plan to have for the demo day is actually bring that hardware. We're going to create a poster that's going to compare both the results from the realistic to ours, to our simulation software, and yep. And that's what we hope to output. That's what we plan to have for demo day. Thank you, and it was a great semester.